owners, roofing can be trouble. Even if you're an architect with expertise, you're more likely to be sued over the roof than all of the components of the building combined. An independent study by Wagner's, Hans, and Inglis found more than 50% of new roofs leaked. 43% were completed behind schedule, and 40% had cost overruns. It's no surprise that a study by the American Institute of Plant Engineers found similar results, with engineers rating their satisfaction with roofing a 3 out of 10. The roofing industry magazines point out other problems with system reliability, safety, toxics, and workmanship. Ask yourself this fundamental question: what other product would you accept that kind of track record from? Phone system? Your car? How about the next plane you get on? The problem is not large companies or the hardworking people in the roofing industry. It's with the roll roofing process itself. 75 years ago, we would accepted phones that worked when they wanted to, and cars that ran sometimes, and planes that had a hard time staying in the air. Fortunately, things improved over time, but the basic concept of roofing, based on rolls, has not. Roll roofing is based on the idea of pre-manufacturing and later assembly. The membrane's made in a factory, cut up into rolls, shipped to the job site, and glued together by the contractor. Sounds simple until you have to do it. Rolls have a defined limit and direction. Edges create seams, and ends create tie-ins. Breaks of penetrations and changes in direction mean cuts. Hundreds of weak spots. Rolls are limited to a flat surface that require even more cuts to conform. A simple void the size of a quarter can cause a blister several feet in diameter. 75-pound rolls are hard enough to work with, no less having to perfectly glue them together with a 2,000-degree torch or 500-degree asphalt. Both can't be touched, stick like flypaper, and are too cold to adhere properly in less than 10 seconds. At completion, you have 3/4 of a mile of exposed seams for every 100 squares, or in the case of single ply, fewer exposed seams, but a fragile system with no redundancy to stop anything if there's even a minute imperfection in the material or the seam. For most industries, 99.9% would be perfect, but for roofing it means a 10 square foot hole for every 100 squares. The claim that such an unforgiving system is quality controlled at the factory is simply a fallacy in real life. Roll roofing application has one of the highest accident rates, and that accident rate is brought to your building. Heavy concentrated deck loads, open fire, toxic fumes, hot asphalt spills, and falling debris are workplace hazards not tolerated by today's government, your neighbors, or your customers. Asphalt fumes and solvents that once were accepted as a nuisance are now controlled toxics under regulation by EPA, OSHA, and the Department of Labor. Roll roofing is designed to be disposable, which makes it needlessly expensive. The hidden cost of disruption is never figured, but can be more expensive than the roofing itself. We buy strength, it deteriorates, we tear it off, and repeat the cycle over and over again. The installation labor and the labor to remove it becomes waste, making roofing debris one of the largest inert contributors to the landfills and disposal harder and more expensive in the future. Every so often, something comes along which causes people to go back and rethink everything, back to the basics. If we look at roofing, we have waterproofing, surfacing, reinforcement, and design. When you look at waterproofing, plastic and rubber have the problems you might expect. They cannot withstand constant sun and can become brittle. They also pose safety concerns, using heat or solvents during application. Asphalt is the most common waterproofing, but by itself or modified with rubber can still deteriorate under sun and water. At 24 months, hot asphalt and solvent-based asphalt can also carbonize and become brittle. But one form, emulsion, which is pure asphalt, liquefied in water and bentonite, has had an exceptional track record in roofing. After the water evaporates, the bentonite forms an inorganic stone barrier that protects from sun, heat, and water. Emulsion eliminates the problems with fire and toxics, and is so watertight that it's also used for reservoirs and tank linings where water is in constant contact. In looking at choosing roofing components for waterproofing, emulsion's a watertight choice. Now let's look at surfacing. Most roofing requires rock granules or coatings to protect waterproofing materials from the sun. This torch simulates the dynamics of sun-type weathering. Plastics and rubber burn easily. The granules of built-up fiberglass roofing only partially protect, allowing the asphalt to quickly burn away. With emulsion, as the top surface asphalt burns away, the inorganic bentonite forms a surface barrier, stopping heat, sun, and weather. The bare surface of emulsion is estimated to weather at a rate of only a few thousandths of an inch a year. If we look at surfacing alternatives, emulsion creates its own. Let's look at the reinforcement that holds the roof together. Unreinforced systems are completely dependent on stretch, which makes them easy to tear and difficult to find punctures in. Unreinforced means fragile in real life. Systems reinforced with polyester have the advantage of some stretch on a diagonal, but low tear strength. The pattern makes a weak direction, even when incorporated with a modified asphalt. Because polyester does not have memory when stretched, buckling can be a problem. Polyester also deteriorates if exposed to sun or heat. Fiberglass has the longest track record and is normally what we think of for high-strength durability. It's inorganic and can stand up to heat, sun, and water. There's good reason why fiberglass is the most popular roofing reinforcement. Now let's look at the most important aspect, design. We've already seen that no matter what the materials, roofs designed using roll roofing have inherent problems. If we look for a natural design, we see nature does not use seams to protect its content, and neither do today's most advanced industries. Since the 1960s, emulsion, fiberglass, and short links have been used as a protective surfacing for roofing, but could never be used as a roof system by itself. In hard binders like resin and fiberglass, strands only need to be an inch in length to achieve full strength, but in a pliable binder like asphalt, short fiberglass strands pull out easily. After 40 years of an industry trying to solve the obvious problem of increasing strand length, WeatherWeld answered it with a simple but effective method using a mixture of short strands intertwined with long strands up to 2 feet in length to form a matrix that makes the long strands lay down and form a solid in one step. The continuous matrix is intertwined for equal strength in all directions. Instead of single filaments, each WeatherWeld strand contains 60 filaments wound together like cable. The snaking pattern provides 5 times the elongation and 16 times the dispersion of movement previously possible. Now let's see what that means. The heating and cooling of a building creates strain. Top performing systems have both strength and elongation to resist this strain. Fiberglass roll reinforcements split quickly, while WeatherWeld's patented matrix design provides both strength and elongation over a wide range. Abrasion to a roof surface from rooftop traffic and mechanical changeouts is an inevitable problem. Granules can partially protect, but they can also hide damage. A screw on the bottom of the shoe can make major problems for a thin stretch-based single-ply or polyester system. Here, stretch without strength means pinpoint weakness. But WeatherWeld's fiberglass composite structure is strong enough to limit damage to only the surface. During equipment changeouts, roofs are subjected to more than just abrasion from a screw. WeatherWeld's patented matrix reinforcement provides the strength to reflect impact without damage. Heavy equipment and thermal cycling can create a tremendous load on a roof. Fiberglass roll roofing fractures easily. Modified systems do not do a whole lot better. Single plies have stretch but can be punctured, and polyester systems can tear. But WeatherWeld has over 2.2 miles of intertwined fiberglass filament per square foot, creating a solid composite structure that has the strength and durability to hold up where other systems fail. If you could concentrate the heat and UV of years of sun exposure, this is what it might look like. The oils in the asphalt burn away, exposing the reinforcement to damage. Even though this built-up fiberglass roll system has the highest fire rating, UL Class A, it cannot stand up to this extreme test. But neither can 1/8-inch solid steel. But against WeatherWeld, the torch is stopped cold. As the top surface asphalt burns away, the inorganic bentonite forms a surface barrier protecting the materials underneath. It's no surprise that WeatherWeld can withstand the extremes of this torch test. Remember, the entire WeatherWeld system, not just the surface, is made of the same proven asphalt emulsion and fiberglass, which has been used as a protective surfacing for the past 40 years. WeatherWeld is the natural evolution of what's been proven successful. WeatherWeld's patented composite process makes it possible to bring the finest raw materials directly to the job site and combine manufacturing and application in one foolproof step. Not only does the system use environmentally responsible materials, eliminating the hazards of toxic fumes and fire, but the manufactured in place solid composite construction eliminates the problems of seams, blisters, and cuts. There's no pounding, no fumes, no fire, no hot to spill, no heavy loads or falling debris. Engineered to be the ultimate in simplicity, one solid unit of inseparable components, fused together and moving with the building, conforming to any shape with strength added where it's needed. The vast majority of roof problems occur in the first few years due to the application problems with rolls and material shrinkage. WeatherWeld eliminates rolls, eliminating the problems up front. And since the composite fuses to an existing roof for itself, your roof can be reinforced before problems begin. A fail-safe system that prevents the cycle of failure. You buy only what you need when you need it, never losing what you've invested by eliminating removal for the life of the building, saving disruption and money. Now let's take a moment to review. In terms of reliability, you have a choice of roll-based systems with hundreds of potential trouble spots at the lamination cuts and seams, or manufactured in place solid seamless composite construction. In terms of durability, you have a choice of standard asphalts, modified, rubber, or plastic material, or asphalt emulsion and intertwined long strand fiberglass composite. In terms of safety, you have a choice of fire, concentrated weight, and toxic fumes, or odorless, cold-applied, environmentally responsible material. In terms of life cycle cost, you have a choice of continual removal costs with disposable systems, or a permanent sustainable system for the life of the building. For some of the country's most demanding clients, the decision's been easy. People who are responsible for lives, for absolute reliability in their products. People who cannot afford mistakes. People who think for themselves and do their own homework. People who will not tolerate hidden costs or disruption to their business or their customers' business. Other manufacturers cannot bring you true seamless composite roofing. Not because of patents, but because it obsoletes their roll factories. The decision's yours to stay with the rolls you know and live with the problems you've grown to accept, or embrace the future and begin today enjoying the benefits of seamless roofing.